Hello. We are from Group 3. We will presenting a topic about meat color.
This is Lily's mother, a housewife. This is Lily, a food tech student. They went to supermarket nearly their house.
The meat looks so fresh. Does it just been slaughtered? I think so, Mom. Meat still red in color. Why does the meat that I have bought at the market turned brown? It is spoiled? Well, to understand why the meat is brown, you need to understand why the meat is red, first. Meat contains lots of proteins. The main one is called myoglobin. Myoglobin is where the red color appears most abundantly, and plays role for the red color in meat. When meat is fresh and protected from contact with air, has the purplish red color that comes from myoglobin. When exposed to air, myoglobin forms the pigment, oxymyoglobin, which gives meat a pleasingly bright red color. The use of a plastic wrap that allows oxygen to pass through it helps ensure that the cut meats will retain this bright red color. Exposure to store lighting as well as the continued contact of myoglobin and oxymyoglobin with oxygen leads to the formation of metmyoglobin, a pigment that turns meat brownish red. While myoglobin. Does it affect when I cook the meat? Yes, myoglobin does affect. Usually in food industry, we use salt treatment and nitrite curing to observe color changes and identify which method is suitable to preserve the color. During cooking the fresh meat, the color changed from bright red color to dark brown. The brown colors start changing from the outer layer into the inner part of the meat. During this stage, the myoglobin will start to break down, denaturation. The iron will lose an electron and form a hemochrome, which is brown in color. The longer the meat is cooked, the more of the myoglobin will be transformed, and the browner the meat will be. Firstly, we were preparing the solutions for both treat and curing and followed by cutting the meat. Then, cure one piece into the sodium nitrite solution, and treat the other piece into the salt solution for 5 days at 5 degrees Celsius. Based on the salt treatment result, the color changed from bright red color to pale brown color. This is because the salts alter the osmotic balance of the meat tissue. When salt is added to minced meat, it penetrates the structure, modifies the electrostatic charges of the myofilaments, and influences the isoelectric point of the proteins, resulting in an increase in water holding capacity, WHC. As WHC rises, water availability on the surface of the meat decreases, lowering light reflection and brightness values causing the meat to look pale brown color. Based on the nitrite curing result, there is no change in color. When the nitrite is mixed with water, it produces nitrous acid and nitric oxide which penetrate the meat and combine with myoglobin to create nitric oxide myoglobin. This causes the characteristic of pink color. Added nitrite binds to the heme moiety of deoxymyoglobin, resulting in fast nitrite reduction to nitric oxide, NO, and heme oxidation to the ferric form. The rapid browning that happens when nitrite-containing brines are added to fresh meats is a visual indication of this reaction. Brown NO-metmyoglobin is then converted to red NO-metmyoglobin under anaerobic conditions by additional reductants such as erythorbate, or more slowly by endogenous reductants in association with metmyoglobin reductase enzyme. The pH of fresh meat is normally between 5.5 and 6.2. From the results, the average value of the control meat is 5.89. For the cured and treated meat shows decrease in pH, which is 5.35 and 5.43 respectively. The nitrite ion forms nitrous acid, which has a pKa of 3.36. In cured meat products, nitrite will deplete continuously forming nitrous acid causing the pH to be more acidic. While in salt treatment, pH value decreases as salt are added. The decrease in pH values after salting is due to the disappearance of phosphates and other basic compounds in the meat. Water holding capacity, WHC, of meat is defined as the ability of meat to retain the water when external force is exerted. Based on the result, water holding capacity on treated meat has the highest due to the high pH after pH had declined to near the isoelectric point of myofibrillar proteins. Chloride ions tend to penetrate the myofilaments, causing them to swell. This causes repulsion between the myofibrillar proteins, which results in swelling of the myofibrils and therefore an increase in WHC. For cured meat, nitrite does not affect the water holding capacity value before and after cooking. My daughter. Now I understood the color changes in meat. So, what happens if I cook the treated and cured meat? Does the color will be retained? Yes, Mom, for both cooked treated and cured meat, it will enhance the myoglobin denaturation. The outer layer of the meat will be grayish tan in color, and the inner part of the meat is pinkish gray color. For your information, the cured with nitrite cannot be consumed because it is banned in our country as it out of safety concerns. As conclusion, color change alone does not mean the meat is spoiled. Color changes are normal for fresh meat. Based on the analysis, the results shown that curing with nitrite is better than salt-treated meat. This is because cured meat can maintain the meat color.